In this lesson, we are starting with no project and ending here. One player marker that moves in 4 directions, keeps the same speed on diagonals, faces the way it travels, and cannot leave the game window. This is the first playable piece of Glimmergrove, and you will build it yourself. This is episode 1 of Build a Battle Monster Adventure with Godot and AI. The written book is linked below if you want every step, recovery path, and checkpoint beside you. Open the Godot Project Manager. There should be no Glimmergrove project yet. Today we will create the project, define the controls, build one small scene, use an AI assistant for one bounded script, and prove the result. We are not building the village or adding artwork yet. The goal is a reliable movement foundation you understand. Select Create, name the project Glimmergrove, and choose a new empty folder you control. Select the compatibility renderer. Leave version control metadata disabled for this first lesson, then create and edit. We use Godot version 4.7.1 stable, standard build. If your project manager moves a button in a later patch, preserve these settings rather than chasing an identical screenshot. Open Project Settings. Under Display, Window, set the viewport width to 1152 and the height to 648. Set Stretch Mode to Canvas Items. This 16 by 9 canvas is large enough to read, small enough to test comfortably, and it will remain the series baseline. Close Project Settings when those 3 values match. Open Project Settings again and choose Input Map. Add 4 actions with these exact names. Move left, move right, move up, and move down, using underscores between the words. Give each action both a W, S, D key and an arrow key. Input actions keep the movement script independent from a particular keyboard layout and make controller support easier later. Create a 2D scene and rename the route Chapter 01 Playground. Add a color rect named Backdrop and stretch it across the full canvas. Add a label named Guide with the text. Move with W, D or the arrow keys. Then add a character body 2D named Player at the center of the screen. X576, Y324. Give player a collision shape 2D with a circle shape and a radius of 14. Save the scene as scene/01_playground.tsc. And now the AI assistant gets one job and one file. Ask it to edit only scripts /01_player.gd. Tell it the player is a character body 2D. Movement speed must be exported with a default of 220. Input must come from input.getVector using the 4 action names, and motion must use move and slide. Ask for typed GD script and a simple procedural gold marker with a small blue facing pointer. Do not ask the assistant to redesign the project or create extra systems. Narrow prompts produce changes you can inspect. Attach the script to player and read the important lines before running it. Input.getVector combines the 4 actions and normalizes the direction, so diagonal movement is not faster. Velocity equals that direction times movement speed. Move and slide asks the character body to travel while respecting collisions. When direction is not 0, the script stores it as the latest facing direction. The drawing code makes our temporary marker visible without importing art. This is temporary presentation, but real movement architecture. Run the project and select this scene if Godot asks for a main scene. Click inside the game window, then test W, S, D and the arrow keys. The marker moves, but right now it can leave the visible area. That is not a failed lesson. It is useful evidence. The player has a collision shape, but the world has nothing for that shape to collide with. Stop the game. Add a static body 2D named World Bounce. Under it, add 4 collision shape 2D nodes with rectangle shapes. One just beyond the top edge, one beyond the bottom, one beyond the left, and one beyond the right. Make each rectangle long enough to cover its entire side. These invisible walls belong to the world, while the circle belongs to the player. That separation will still make sense when this playground becomes a village. Before the final check, practice one recovery. In the script, temporarily misspell move left in input.get vector. Run the scene and press left. The other directions work, but left does not. The script is reading an action name that does not exist. Restore the exact spelling and run again. When one direction fails, compare the input map name with the script before rewriting movement code. Now complete the full play check. Press W, S, and D one at a time. Repeat with all 4 arrow keys. Hold 2 directions together and confirm the diagonal does not move faster. Release every key and confirm the marker stops. Finally, push against the top, bottom, left, and right edges. The marker must remain visible on all 4 sides. If every check passes, you have a controlled character body, reusable input actions, normalized movement, facing state, and collision boundaries. Change movement speed from 220 to 160 and run once. Feel the difference, then choose the value you prefer. That small experiment proves the exported number belongs to you, not the assistant. Save the project. The known good Chapter 1 checkpoint and its SHA 256 checksum are linked below if you need to compare or recover. In Episode 2, we will replace this playground with Fernwake Village and build a real walkable space from the same movement foundation.